so that you know, so that you're all aware. It's a great honor and pleasure to have with us Professor Brenda Eskenazi, who is Professor Emeritus of Public Health at University of California Berkeley, and she is the director of the Center for Environmental Research and Community Health, SEARCH. And today she'll be presenting data from the CHAMACOS cohort, 25 years of data working with agricultural families in the Salinas Valley in California. So Brenda, the floor is yours.
Thank you. Okay. Got it. I know, it's great. Can I stand? Do you have a good mic if I stand? Okay. Thank you, everybody, for coming. It's a pleasure for being at the University of the Aegean. And thank you for the Erasmus group also for inviting me. So thank you. Today, I'm going to talk about California. And that's where I live, and that's where I work. About 25 years of working with agricultural families. But at the end, I want to talk about how what we've done in California is relevant to here in Greece and in Europe. So just to give you a little bit of background about agriculture in the United States, it's 5% of the gross national product is agricultural related. It's a lot of money. Billions of dollars are directed to farm production, but we also use a ton of pesticides. 1 billion pounds of pesticides are used nationally every year in the United States. We have lots of farm workers, and most of those farm workers are immigrants, and most of them are immigrants from Mexico or Central America. They tend to be of low income and have very little knowledge of English, our primary language. California is the leading agricultural state in the United States. We produce about 50% of all fruits, vegetables, and nuts, but we also use a ton of pesticides. And I need to get up there and point, but I can't point because, can I use the mouse? How do I, oh, okay, because I'm on the screen, right?
Yes, you are.
Okay. So here is California, and this is what we call the Central Valley. And the valley that I do my research in is here, which is called the Salinas Valley. The Salinas Valley is called the salad bowl of the United States. We also use a lot of pesticides in our salad bowl. And about 50% of the farm workers also immigrate from Mexico. You can see there on that map, this map here, this is the Salinas Valley. Here are the little dots here that represent where the people in our study lived. And this also represents the amount of pesticides that are used in the Salinas Valley. So the darker the color, the more red the color, the more pesticides that are used. So I can use that and this at the same time. Okay. Wait, which way does it go? Okay. The study I'm going to be talking about today is called the CHAMACOS study. CHAMACOS means kids in Mexican Spanish, and it stands for, it's an acronym that stands for the Center for Health Assessment of Mothers and Children of Salinas. The objectives of our study are threefold: to measure the exposure to pesticides as well as other environmental chemicals in pregnant women and children in the Salinas Valley, to determine that relationship with their health, maternal and child health, and to work to reduce exposure. So not just to study and observe, but to intervene and to reduce. In 1999 to 2000, we enrolled 600 pregnant women living in the Salinas Valley. We enrolled women that were living, that are working in the Salinas Valley, but they were being served by clinics that served farm workers. They themselves were not necessarily farm workers. About 44% worked in agriculture during pregnancy, but they almost always lived with a farm worker. So these are low income, Spanish speaking, mostly born in Mexico, low income and low education population. The one thing I do want to point out is that about 55%, 54% lived in the United States for less than 5 years. We didn't actually ask them about their documentation status, or if you will, their legal status about being in the United States. But we estimate, based on US amnesty laws at the time, that something like 50% to 75% were illegally, we like to call it undocumented, in the United States. So they had gone across the border, not with papers. Since then, we have followed the mothers and the children every year or two. We follow them at birth, at 6 months, 1 year, 3.5 years, 2 years, 3.5 years, 5 years, 7 years. At 9 years, we enrolled a second cohort of kids that were also born at the same time as the first cohort. And we followed them through puberty. Every 3/4 of a year, we examined them. And at 12 years, 14 years, 16 years, 18 years, and now the kids are 22 years old. So we have followed a migrant farm worker population for 22 years. And if I thought I was going to do this, I probably wouldn't do it again, because it's not easy to follow a migrant farm worker population. We have evaluated the health and development of the children at each visit. We've also interviewed their mothers and teachers. We tested the children, done neuropsychological examinations. We determined when they entered puberty by physically examining them. We did anthropometry, measuring their body mass, as well as liver function and metabolic disease. We evaluated their respiratory function. We assessed their brain function. We collected data when they entered into adolescence about risk-taking behaviors. And we also performed, we're performing right now, our MRIs on the mothers, looking at cognitive function. We have collected samples to measure pesticides, as well as other chemicals, as well as other health outcomes. So we have collected urine, blood, and breast milk from the mothers, and from the fathers, we collected urine. From the children, we have collected almost everything you could possibly collect: urine, blood, saliva, hair, teeth, and we also did environmental samplings of house dust. We have collected more than 400,000 biological and environmental samples, and we have stored them in -80 degrees for up to 25 years. It's because of this very large biorepository that we can continue to do state-of-the-art research. We also collected residential information, every single home that the family lived in. The mother lived in during pregnancy, and the child lived throughout their lives, and we geocoded that home. That meant that we could then link environmental exposures to where they lived. And in California, we are unique in the United States and in the world in having something called the pesticide use reporting data. It means that every pound of pesticides, the date and time of location, is actually recorded, and it has to be recorded accurately, and that is enforced. So that means that you can geocode exposure to different pesticides to where that person lived. And that's another measure that we have of exposure. In terms of agricultural pesticide use in Monterey County, which is where Salinas is located, we can see that over time, we started the study here in 2000, and over time, you can see that overall, pesticide use has decreased. In particular, organophosphates, which is the pesticide I'm going to be talking about mostly today, has greatly decreased, whereas other pesticides, in particular, this sliver green line, which is the neonicotinoids, the ones that are being considered for bee colony collapse, is actually on the increase. It's hard to see on this graph. And glyphosate, which is a major weed killer, is also on the increase. So our initial focus has been on organophosphate pesticides. And at the time that we did our study, about a third of all insecticides used in California and in the United States, and for most part the world, were due to use of organophosphate pesticides. Up until year 2001, in the United States, organophosphates were allowed to be used inside the homes for insect infestations. But in 2001, that was taken out, and they were still being allowed to be used in agriculture. We know that the way that organophosphates work is that they affect the nervous system of insects, but that's also what we wanted to know. Do they affect the nervous system of humans as well? We know at high doses, there has been many reported cases of poisonings of workers applying organophosphates, but also of children who ate organophosphates by accident. So we know that they affect the neurological system at high doses. At the time we did our study, we didn't know if they affected at low doses. They are eliminated, these organophosphates are eliminated in urine in the form of dialkyl phosphate metabolites, or DAPs. And I'm going to refer to those DAPs over and over again. So dialkyl phosphate metabolites are DAPs. So at the same time that we did our study in year 2000, the US Centers for Disease Control had developed a method to measure these pesticides in bodily fluids, and particularly urine. You've probably heard about DDT and other pesticides that could be measured in blood, but those are very different chemically than the organophosphate pesticides. And up until 2000, we didn't know how to even measure them in humans. So in 2000, at the same time that we started our study, CDC did a study across the United States called the National Health and Nutrition Examination Survey, which is called the NHANES study. And every 2 years, the NHANES study happens. And we were able to compare the levels of exposure to our population with the levels of pregnant women in NHANES, or women of reproductive age in NHANES. The same laboratory analyzed our urines as analyzed the urines for the general US population. And so what we see is that the general US population had substantially lower levels. I think I have to put this down, and had substantially lower levels than the CHAMACOS women. So we found that these pesticide residues, or these DAPs, of all pregnant women in CHAMACOS had much higher levels than in the general US population. It's very hard to move this ball. At the time that we did our study, I said that CDC had developed a method to measure these organophosphate metabolites in urine, but they hadn't been able to measure it in breast milk, for example. Now we know we can measure DDT in breast milk because they're very long-lasting chemicals, but these short-lasting chemicals like these organophosphates, we didn't know if we could measure them. And so we worked with CDC to develop a method to measure these organophosphates in breast milk. And we found that 97% of the breast milk samples that we measured had evidence of these organophosphate contamination. So that means that pregnant women were exposing their fetus, but they continued to expose their fetus as they breastfed their children. We then also measured these organophosphates in the house dust samples that we collected. And we found that in 100% of the house dust samples did we find evidence of organophosphate contamination. But in spite of all of this, many people questioned whether our population was exposed because they were occupationally exposed, or because they lived near exposure, or because did they get it from their food that they ate. So we did a study where we actually gave, this was a very expensive study, where we gave children conventional food, and we also gave them organic food, meaning food that wasn't grown with pesticides. and we look to see whether the levels of these DAPs in the children's urine were different if they ate organic food versus conventional food. Now, you might think this is a no-brainer, but at the time that we did our study, people were not convinced that they were getting it through their food, okay? So to make it even more complicated, we did a study in Salinas, the agricultural area, and we compared children, also Latino children, in Oakland, which is where I live, in an urban environment. And we showed that if you compare people eating, the children eating conventional food versus the time that they were eating organic food, both in Salinas and in Oakland, if you ate organic food, you had lower levels of these organophosphates in your urine. But looking at the same exact slide in a slightly different way, you can see that in Oakland, whether you ate conventional or organic, you had lower levels than you did in Salinas. That told us that the food was a major source of contamination for exposure to the organophosphates, but also where you lived. So living in an agricultural community exposed you, but also eating conventional food exposed you. And these are children that we're talking about here, actually 2 to 5 year olds. We have now shown that these higher levels of organophosphate metabolites, those DAPs, in the mothers during pregnancy were associated, and I'm going to show you 25 years of research in one slide. Shorter pregnancies, meaning they gave birth earlier. It's very hard. Shorter pregnancies. I can't see if this is working. Yeah, this is now working. That would have made life a lot easier to begin with. Okay, shorter pregnancies, abnormal reflexes in neonates. When you're born, you have certain reflexes and they're supposed to disappear. And we saw more abnormal reflexes. And by the way, this was confirmed in a study at Columbia University in New York City as well. Poor verbal abilities in preschool children. Problems of attention at age 5. Poor social skills at age 7, poor executive function at age 12, poor working memory at age 12, traits similar to autism at age 2, and again at age 14 years. We have also shown that those prenatal organophosphate metabolites, the DAPs, were related to decreased IQ. And we tested every child ourselves. This is a Wechsler intelligence scale for children at 7 years. And there are subsets. This is a full scale IQ here. And this makes up the full scale IQ. Those of you who are not familiar with beta coefficients and 95% confidence intervals, if this is the 95% confidence intervals, the 2 wings on the side of the diamond, and that if they fall below 0, this 0 line here, that means they're statistically significant. Or if they go above that 0 line, that means they're statistically significant in the other direction. Okay, so what we see here is that across the board, the mother's levels of organophosphates during pregnancy were associated with decrease in working memory, significant decrease by about a 4 to 5 point decrease in IQ. And to put that in a frame of reference, the standard deviation in IQ is 15 points. So this is about 1/3 of a standard deviation. If you move a whole population of humans down 1/3 of a standard deviation, you are going to have a lot more kids that need special services. A lot more kids. So this is a substantial association, I should say. And you can see here that it's working memory, processing speed, verbal comprehension, perceptual reasoning, and all of these together produce about a 6 point on average decrease in IQ per 10-fold increase, because on a log scale, of the mother's dialkyl phosphate, the DAPS in pregnancy. To put it another way, which might make it easier to understand, if you take the mother's levels and you divide them into thirds, so you have low levels, medium-sized levels, and high levels, you see about a half a standard deviation difference in the child's IQ between those that had low levels and those that had high levels of metabolites. If there's any question, you should stop me also. Okay, we also got very interested when they entered adolescence are those maternal levels during pregnancy of those DAPS related to kids taking more risks as they got older. We saw that they affected their executive function, meaning the choices that they made on tests, but how about in real life? Did they take more risks? And we see in our population that there are a lot of children that at age 18 years, about 70% who are having delinquent behaviors. That's not so unusual, but in this population, it's of great concern because Salinas Valley, Salinas, is one of the highest homicide rates and gang activities in the United States. It hovers between the first and the third place in the United States. So we are talking about a very high-risk population, and we don't need to be adding any concern by exposures that they had in utero to this population. So what we did is we looked at the mother's DAPS during pregnancy and delinquent behavior in the children 16 years later, and found that children whose mothers had higher levels of exposure had more frequent delinquent activities, and they had delinquent activities younger than children with lower levels in this same group. And I just want to explain something for those of you who are not familiar with cohort studies. And people have asked me this question. There is no control group here. What we have is a population of hundreds of people, some with higher exposure, some with less exposure, some with virtually no exposure. And like correlation, you are looking at the relationship between exposure and the outcome. You don't need a control group because within your population, you have a gradient of exposure. Okay, so what we're looking at is an increase in that mother's DAPS in pregnancy with earlier onset of delinquent behavior. When the children entered late adolescence, and we are living in a relatively rural setting, we wanted to be able to look at their brains directly. But we didn't have the ability to do that out in the fields. And so we had to come up with a method that allowed us to look at the functioning of their brains easily in a classroom. And so what we did is use something called functional near-infrared spectroscopy, or FNIRS, and it uses optodes. It uses light and how light reflects, and it has to do with how much blood is in the particular part of the brain, how much blood is being activated in a particular part of the brain. And so it's a less invasive, rather than putting someone in a tube like in an MRI. What do you call it? Does everyone know what an MRI is here? Okay. Not putting someone in a tube in an MRI, but rather you put a little cap on them, and these caps have these optodes here, and it's much less expensive than doing an MRI. It's portable, and these optodes tell you the hemodynamic changes at the cortical surface. So this is the human brain, and these are the placements of these optodes here over the brain. And then we can look to see when the brain is working, how much oxygen is used in different locations. And we can see that activity on a monitor, and it looks like this on the monitor. And then we have to use very complex statistical analyses to analyze those data. And what we found in the 15-year-olds is those mothers, those kids of mothers who live closer to organophosphate use, there was decreased activation in certain parts of their brain. And it was related to how much exposure the mothers had during pregnancy. So the particular areas are in the prefrontal cortex, and these areas are related to executive function. And so we see altered brain activation patterns related to executive function when these kids were doing tasks that had to do with memory and executive function. And it was related to how much exposure the mother had during pregnancy 16 years before. So we're seeing long-lasting associations of early life exposure to organophosphates many years later. CHAMACOS, our study, has contributed to a dramatic reduction of organophosphate use in California. We've been told this by policymakers. We're proud of that, but it's not just California. What happens in California happens in the rest of the United States. What happens in the United States happens all over the world. So we're proud that CHAMACOS, our little cohort of 600, has contributed to that. But as I said earlier, at the same time that there's been a decrease in organophosphate use, which is that red line, red group there, we have seen an increase in change in global pesticide use. This is not just the United States, this is globally over the last 3 decades. And there's been an increase in mixtures of pesticides. So we looked at one class, organophosphates, but there are multiple different classes of pesticides. It is very difficult to be able to look at multiple classes of pesticides and how they work together, for example, in the human brain, right? Because they might also be synergistic with each other, meaning they maximize the effect. So how do we do that? Well, the problem is that many of these pesticides can't even be measured in the human body yet. We don't know how to measure many of the pesticides. So we were lucky because in California, we have the pesticide use reporting data. And so we can look at location next to different classes of pesticides. And that's exactly what we did. So for example, here's a map of sulfur use, which by the way, sulfur is used also in organic growing, not just conventional. Here we have the manganese fungicide use. Here we have glyphosate use. And then we can put this all together and look at it statistically, because as you can see on this heat map, these are many different kinds of pesticides here. And you can see by the intensity of the blue that there is a high correlation between if you use pyrethroids in one location, you're going to be more likely maybe to also use organophosphates. So we had to think of a way of putting it all together. And so we use different kinds of statistical methods, which I'm not going to get into a great deal of detail, called Bayesian profile regression methods. And we were able to show that, remember that IQ finding that I showed earlier? That really, if you look down here, this is going to be hard to explain. These are quartiles of exposure. So where it says 4 here, that means it's the highest quartile of exposure to that particular pesticide. And if you say 1, it's the lowest level to that particular pesticide. And what we have here is a cumulative distribution. And this red color here means that these kids actually, this is the IQ, are actually performing the best. And this purple one here, right here where the blue arrow is, are where the kids are performing the worst on the IQ. So who are these kids, the ones that are performing the worst?
As it turns out, these are all these different pesticides along the bottom. You don't need to look at each one of them, but it's those kids who had the highest, whose mothers lived closest to the highest application of all the pesticides across the board. So it's not just the organophosphates that I was studying, but it's accumulation of all of these pesticides. And what we're working at right now is figuring out an even more sophisticated way to look at these complex mixtures, because frankly, we live in a swimming pool of chemicals. And I don't just mean pesticides. Here we've just classified pesticides, but we haven't considered phthalates or phenols that are in personal care products, or things that are in your sunscreens, or things that you're using to clean your house. And we have to really consider these complex mixtures in a way that we're not sophisticated enough yet to do, either because we can't yet measure many of these chemicals yet in the human body. We don't have the statistics to be able to do it. And we need large sample sizes. So we have studied many of these chemicals, not only pesticides, organophosphates, I've talked about, pyrethroids, fungicides that contain manganese, organochlorines, fumigants, glyphosate, sulfur, fire retardants like flame retardants, bisphenol A and other phenols, phthalates, other chemicals in personal care products, and also air pollution, PM 2.5. We have learned, and full disclosure is I was originally trained as a psychologist, that we really need to look at not just the chemical environment, but we need to look at the social, psychological, anthropological environment. I said that for your sake. And that means that we need to be able to look at all the confluence of all of the factors that influence child development. But we also need to look at the biological factors like genes, right? And so that's exactly what we did. We said to ourselves, are there some kids that are more susceptible to the effects of organophosphates because of their genetic makeup? We know now that there is a class of pesticide, a class of genes that code something called peroxidase enzymes. And it's these enzymes that are involved in the detoxification, making organophosphates less toxic in the human body. The amount and efficiency of those enzymes depend on this class of what we call PON1 genes. And we showed that the amount of enzyme depends on how old you are. So this is actually in a very important graph here. We used to think that exposures to children after the age of 2 were going to be safe. Well, really what we thought a long time ago is that bad chemicals don't get through to the brain because the blood-brain barrier stops it, and it doesn't get through the placenta, but that's not true, okay? And then we said, well, we only have to worry for kids up to age 2. What this graph shows is that it's not until age 7 that children have the same level of these PON1 enzymes in their body as their mothers. That means that they're less able to detoxify organophosphates until middle childhood, much later than we ever thought. And so we were concerned about exposures to the children, not just from the fetus, but in the children as well. We then asked the question, if moms that had the same exposure, but some moms had different genetics, would children of moms with different genetics more or less affected because their mothers were less or more able to detoxify organophosphates? So remember I showed you before that the mother's levels of DAPS in her urine during pregnancy were related to about a 6-point on average drop in full scale IQ in the children at age 7. Okay. If the mothers had a high level of this peroxinase, meaning she was really able to detoxify those organophosphates, this is increasing exposure and IQ. What you see here is that there was no association. No association. Same level of exposure, no association, because the mom was able to detoxify these organophosphates. If she had a moderate amount of these PON enzymes, you see about a 4-point drop on average of the children's IQ. And if the mother had low levels of enzyme, you now see a 10-point drop in IQ. So it's not just the exposure to the organophosphates, but also the mom's ability to detoxify that chemical based on her genetics. Everything I've shown you so far shows a relationship with prenatal exposure and neurodevelopment, neurobehavioral development. Now what I'm going to show you is it's not just about brains, and it's not just about prenatal exposure. So we can actually test lung function in children. I don't know if anyone here has had lung function tests where you breathe in, you see how fast you can expire or inspire. And we see absolutely, remember I said before, this is the no effect line. And if it straddles that no effect line, it means it's not statistically significant. So we see absolutely no relationship between prenatal exposure of the mothers levels of DAPS and lung function in the children age 7. Absolutely nothing. Now you look at the child's exposure during early childhood, between the ages of 0 and 5 years of age. We measured for these DAPS in the children up until age 5. Okay. And now we see that respiratory function is impacted by child's exposure to these organophosphates during childhood. So although we see a relationship with prenatal exposure and neurobehavioral development, we see a relationship with childhood exposure and respiratory function. We're also interested in cardiometabolic disease in the CHAMACOS children, in part because we have learned that these children are very high risk. I showed this slide to the class earlier. About 10% of children have metabolic syndrome, which means they are at high risk for developing diabetes and other cardiometabolic disease. About more than 50% of our kids are overweight or obese. And we also see that about 15% have elevated liver transaminases enzymes, which put them at higher risk for develop liver cancer later on. So we are seeing a high risk population, not just because of the gang activity and homicide rate, but also because of what's going on in terms of their cardiometabolic risk factors. We continue to look at all of those factors when we're looking at the CHAMACOS study. Health and development are determined by many factors other than chemicals, and it behooves us to have a multifactorial approach to child development. You can't just look at one thing, especially when you're talking about neurodevelopment. As I said earlier, Salinas Valley, our youth is at high risk. The teen birth rate is double the the California average, and we have the highest, we're very not proud, of the highest homicide rate in California. We have also shown there's something called adverse childhood events. It was a scale that was developed in California in the Kaiser Hospital, a way of looking at adverse events in childhood. And they showed that these adverse events in childhood had multiple effects on the children throughout life as they developed. Not just psychosocial effects, but cancer, cardiometabolic diseases, a lot of different things. And what we found is that the mothers had at least, and when I say adverse events, I mean things like having a parent that's in prison, being raped, witnessing a crime. I'm talking about real major adverse events, but also things like parental divorce. So less, more common events as well. And we showed that the number of adverse events in the youth as well as in the mothers was very, very high, and that it's transgenerational. That mothers that had high adverse events also had children with adverse events. And in a paper that we just submitted yesterday, we also showed that the mother's adverse events are related to the child's depression and acting out or attention deficit disorders. And it's not just operating through the child's events. So there is a transgenerational impact on the child. Okay, now it's not working. Oh, we've also shown that those maternal ACEs, we can actually look at epigenetics. So we also look at epigenetics, which are protein changes in the genome that are not encoded from generation to generation, but are temporary. And we can look at something called epigenetic aging. There are different clocks that are developed to epigenetic aging is not necessarily a good thing because we don't want to be aging faster than our chronological age. Certainly, as you get older, you want to be aging less. That the mother's ACEs were related to the epigenetic aging. That means the kids were aging faster. So we're seeing biological impact of the psychological and social factors. This has implications for what we saw today in the communities. All of our children are US citizens. They were all born in the United States. But as I said earlier, between 50 and 75% of them have parents, maybe even closer to 100%, have parents who were immigrants. And parents that were immigrants was like 100%. Parents that were undocumented was probably closer to 75%. But again, we don't ask that question. A week after the 2016 election, when Trump was elected in the United States, we have a youth community council. Do I have to end at 4:30? 5:30? Do I have to end in 5 minutes? Okay. Okay. When Trump was elected in the United States, we have a youth community council of youth that from the community, and they come and meet with us and advise us on our research. So we asked them, what should we study? And in this meeting, it was the week of the election, I had 3 kids break down in tears. And we asked them why. And one kid said, I'm afraid I'm going to lose my parents. Another one said, I'm afraid that they're going to be sent back to Mexico. Another one said, my sister is not legally in the United States. She wasn't born here, and she's on DACA, which means she's going to not receive funding to go to college. And so here we had US citizens concerned about the impact of the US immigration policy on their children, on themselves. And a quarter of these children were worried about family separation due to deportation. We showed that those concerns about immigration had real effects on the health of the children. We had clinically higher measures of anxiety in the youth, US citizens, youth, 16-year-olds. We also showed that the parents were more likely to report anxiety in the youth, in their children, and the children had poor sleep, which means they were having more trouble focusing in school. In the mothers, who, remember, many of them may have been undocumented, we showed that they had increased cardiovascular risk factors after that election. So there are real impacts on the health and well-being of people because of our immigration policies. Environmental justice. What happens when pesticides and social stresses are combined? It's like a double jeopardy. And if you add genes to it, it's a triple jeopardy. We showed that the effect of OPs, of organophosphates, were stronger in children experiencing early life adversity. So that among kids with low family adversity, remember I said it was about a 6-point on average IQ drop, right? You only see about a 2.5-point IQ drop if the families had low adversity. But if there was high family adversity, then you're seeing an 8.2-point decrease in IQ. So now you see what we call effect modification by genes and also by adversity, social factors. So what are our next steps? We are now following up the children who are no longer children. They are 21, 22 years old. They are having kids themselves. We are following up their kids. We're looking at respiratory function. We are following up the mothers. We are looking at cognitive functioning and early risk factors for Alzheimer's and dementias in the mothers, and seeing whether those adversities, whether those exposures are going to accelerate the affect the cognitive functioning of these women as they get older. But our ultimate goal is to reduce families' exposures to pesticides and other toxicants. We operate at the individual level, the community level, and the policy level. We have community involvement at every level. We have a community advisory board that's comprised of growers, the farmers, the employers, the youth, the participants, the farm workers, and they all come together in a community advisory board. As a community-based participatory research project, we have educated more than 40,000 farm workers and their families on how to reduce pesticide exposure to protect themselves. We have taught children with puppet shows on how not to get exposed to pesticides. We have sent out newsletters, and we've had community meetings, and at those community meetings, we have Zumba, and we have food, and we have partying, but we also have education, and we tell them the results of our studies, and we have a regular newsletter. We also engage the youth as researchers in our community. We recognize that in this low-income, low-educated population, it is our job to bring science, to make the kids interested in science. And so what we've developed is peer-to-peer research. We have youth become the researchers. We teach them how to be researchers, and they do the research on other youth. And so we did one study. I'm only going to talk about this one study. Kim Harley, who was supposed to be here with me, is not here. The youth actually interview others. So we train them in study design, we train them as research assistants, and we give them money so that they don't have to work in the fields, that they can actually learn about science during the summer break. We gave them wristbands, and these are silicone wristbands, and on those bands, we can measure the pesticides in their environment. We have done house dust samples, and the kids are doing all of this. We teach them all of this. And they don't do this part, the urine samples. we get an adult to work with the urine because these are under 18. And we also have the youth go to Sacramento, which is the capital of our state, and tell the policymakers about the results of the studies. And these are all farm worker kids, low income Latinos, and they also have developed radio novellas, which are like comics or stories, and go on the radio themselves with radio stations, Radio Bilingue, to present the results of the study to other youth and to their families. So we get the youth involved in research from the ground up. We found those wristbands that I talked about, that I'm just going to cut this short, that those people who had a doormat outside their door, because remember, these are farm workers coming home with dirty boots from the farms, and who clean their home daily, had actually lower levels of these are pyrethroid pesticides on their wristbands. And so what did we do? It's written in Spanish in reality, not in English, but I wrote it in English here, is that we printed 1,000 doormats, and the youth researchers distributed those 1,000 doormats to people in the community to actually get them to take off their shoes before they entered the house, because we showed that if they took off their shoes before they entered the house, we have lower pesticide levels in the house dust and on the wristbands. And by the way, it was the youth that came up with that idea. Okay, and this is another idea that the youth came up with and also executed. This is a mural. This mural is the length of this room. Okay, we worked with, and if you notice the style, I don't know how many people know, Diego Rivera and other Mexican artists, but the style is a very particular Mexican art style. And we worked with a Mexican muralist. The kids painted this. And this mural is about how to protect yourself against pesticide exposure. So here you can see there are people wearing hazmat suits if they're going to be applying pesticides, making sure that the pesticide applicators are properly drained, and also about the showering and washing the strawberries really well. So this mural is now, well, first of all, it used to be in a museum, but now it's at a mall where the farm workers go shopping on the weekends. And as I said, it's the length of this room. It's about this tall. So one of the goals for us is to foster in our community, in the Salinas Valley community, the next generation of environmental health leaders. Our youth council, we are proud to say that every one of them went off to university, except one who went to the military, but now he's at university. And this is a major step forward. I mean, these kids are working after school to support themselves and their families. And many of them have gotten into UC Berkeley, which is a premier university, UCLA, another premier university, to be able to not work in the fields, but to actually look forward to an education in science. I am also working on a project with the Monterey Bay Aquarium, which is one of the leading aquariums in the United States, to educate the teachers in our community about environmental health. And so we're using art as a way of teaching teachers to teach kids we have our 3 projects. One is plastics and microplastics and plasticizers, climate change, and also the pesticides. And that's a joint partnership with the local college, Cal State Monterey Bay, and also the aquarium, as well as of CHAMACOS. We have contributed to local, state, national, international chemical policy.
but you can't have a lecture on public health without talking about COVID. So I'm going to talk about COVID for a second. Do I have a second? Okay. March 27th, so it's about 7 days after our shelter in place in California, United States, where we had to like freeze our lives and just stay inside. I wrote a op-ed piece for the local newspaper with a lawyer and a family practitioner. And I said, I've been working with these farm worker families for 25 years, we're in trouble. These farm workers live in difficult situations, they're low income, they live in crowded housing, they don't have good access to medical care. We need to make sure we protect the farm workers because, by the way, we need them. Otherwise, we're not going to have food on our table. And that was a first for me because I actually came out of my ivory tower academia and became a community organizer. And I really didn't know what I was doing. It was a lot safer in the ivory tower. So we had our first meeting. I formed something called the Monterey County Coalition of Agriculture to get all the different people to the table. One thing that 25 years of working with farm worker families did is it got me to be loved and hated by every single group in the community, depending on who they were. Okay, and so I formed a coalition with a partner called the MC-COA Coalition, where we organized by the end of November, 6 months later, 150 leaders of the community, including advocates, lawyers, medical people, farm worker advocates, farm workers themselves, church leaders, you name them, they were all sitting on our Zoom, because it had to be Zoom, all sitting on our Zoom calls every week, and the growers. Now, I don't know how many of you know about Cesar Chavez and the history of the farm workers in California, but the growers and the farm workers have not gotten along. Over COVID, they had to get along. And since I, as I said, loved and hated by everybody, I was able to bring together all of these people and say, listen, guys, we have to really work together or agriculture and your pockets are going to suffer, but the farm workers are going to suffer too. And so what happened is that we formed an unprecedented alliance to protect California farm workers. And because of that, we were able to do our first epidemiologic study on farm workers and showed, I'm going to go quickly, is that farm workers had about 4-fold higher risk of COVID early on in the pandemic compared to the general California population. It was no surprise to me. They live in extremely crowded conditions. I mean, we're talking about an infectious disease here. They had no place to shelter. They had no medical care. We showed that that was a risk factor, overcrowded household. We showed that there are children in place. We showed that they have no access to washing machines, no place to shelter. All of those were going to be risk factors for getting COVID. I'm going to skip over some of these right now. But many of the farm workers were telling us that they couldn't afford to stay home. So they were going to work sick. And what does that happen in the middle of a pandemic? More people get sick. They were afraid of losing their jobs. So we had to get the growers to realize that we needed to change the rules, that we needed to make sure that we enforced and reinforced and provided for the farm workers so they could stay home and still receive their pay. And they could also, if they don't have a place to shelter, we could find hotel rooms for them to actually shelter in place in. And we could provide medical care to them where they were sheltering. And all of this happened because of this coalition.
COVID has impacted the farm workers' lives in many ways. We have shown that they had inability to pay their bills. This population, as ironic as this sounds, something like 40% of the farm workers have low food security. It's ironic. They put the food on our table and they have low food security. And what we showed is that the pandemic was making them have lower food security, higher low food security, because they couldn't work. They weren't getting paid. And not only were they supporting their families in the United States, but they were sending remittances to their families in Mexico. And those families were suffering. So we have an international dilemma here. Our research led to, very early on in the pandemic, the first group other than medical staff to be prioritized to get vaccination. When there was little vaccination available, the farm workers were in the first group. And it's because we showed that they were at higher risk. I'm very proud of this, by the way. It was really hard becoming a community organizer since I didn't know what I was doing, but it was the most rewarding thing that we could do. I actually retired 6 months before COVID, and then my husband sitting here, I came back 150% to make this, knowing the farm workers and what they were going to suffer, happen. We are now at this very moment studying long COVID in the farm workers. We are seeing very high rates of long COVID. In the general population, it's around 40%. In the farm workers, we're seeing about 65%. We think it may have to do with the high rates of obesity and diabetes in the population. Some of that is genetic, some of it is not. And so we're very concerned about the continuing long-term health problems and the fact that it's really hard to work the kind of work that they do when they can't breathe. So we're looking at that right now and trying to make sure that they get compensated like everybody else for long COVID. I'm going to skip over this. There is so much left to do to improve the health of farm workers and their families in California. But what COVID showed me is what's possible too. It pulled back the curtain and showed the lack of affordable quality housing. If you know the geography of the area that I'm talking about, it's very close to one of the wealthiest areas in California, Silicon Valley. And Silicon Valley is spreading further south. And so the housing in the Salinas Valley is becoming incredibly expensive. So it means that more farm workers, you'll see a dozen farm workers living in a one-bedroom apartment because they have no place to live, or they live out by the river. So it's pulled back that curtain of lack of affordable quality housing because we realized that they were going to be at higher risk for getting COVID. It also showed us the high levels of food insecurity and the need to give food to farm workers. The irrational immigration policies of the United States, the hierarchies in the farming sector, and the lack of trust between farm workers, advocates, and growers. But it also showed me what is possible. It was the clinics that I have worked with for 25 years who was started by a former farm worker who's became an OBGYN, obstetrician, and the growers who paired together to vaccinate the farm workers. There would have been an animosity between them before, but they realized that they were in this together. And they worked to make sure that something like 90% of farm workers are now vaccinated. Very high vaccination rates, higher than the general US population. We search continues to collaborate with other studies on chemical exposures and children all over the world. We hope to develop something here in Greece. And that brings me to my last thought.
how is what's going on in California relevant to what's happening in Greece and what's relevant to what's happening in the European Union? Today I went to the camps. Thank you, Kostas. And I got to see about immigration here and in the EU. It's not different in the United States. What you see here is going to impact these kids too. The psychosocial trauma. Agriculture. This is an agricultural nation. I think I ate cucumbers and tomatoes for breakfast, lunch, and dinner. And those cucumbers and tomatoes were probably not grown organic, and they probably had a lot of pesticides. And I can tell you that the one study that has been really well done in Israel, where it's a very similar diet actually, showed unbelievably high levels of those organophosphates in the kids in Israel. I would suspect you're going to see high levels also here in Greece and in other countries where there's a high intake of fruits and vegetables, which my other line for public health purposes, eat your fruits and vegetables. Do eat your fruits and vegetables, just wash them well, okay? And the third thing that I think that our study in California points out to Greece and to other countries is those low-income workers are essential, but they can't operate without food and good shelter. And we need to protect them. And if you want to be selfish about it, to protect ourselves. I'd rather us not be selfish about it if we want to protect them. But, you know, if you can't do that, it's really, we're all in this together. And with that, I'd like to, takes a village. In this case, there are lots more people that I couldn't get photographs of. Actually, Olga is one of them. She worked with us. I'd like to thank them. And also I'd like to thank almost all of our funding comes from federal grants from the US. We don't like to take money from non-federal grants because we want to be able to report what we see. And a special thanks to the families and the children who are now adults. This is one of them when she was 12. That's the t-shirt we gave her when she was born. And by the way, the mother is a cleaner. She doesn't work in the fields. And because of us, she uses green cleaning products. And I'd also like to thank the farm workers for all the work, the hard work that they do. I spent a day picking strawberries, and I will say it's the hardest thing I've ever done. And thank you for being here, and that's our website.